Okay, what we have here is the prototype Zat gun. So before boxing it up, I thought I'd run through what's inside and the very few modifications that I had to make to the plastics. So if we start at the top here, we're fortunate with the loudspeaker that it ended up being thinner than I was expecting. So there's stacks of space for that. At the moment, it's held in just a couple of tiny grooves made there and a little indentation there, so it's good enough for now. But I imagine that building up some pillars so that they can be screwed in would be a better way of doing it. The cables from the top first run down this arm, and it might be handy just to take that corner off a bit, and then they go underneath the loudspeaker. And because there's a lot of restriction space here, I've drilled a hole through from underneath the servo into the main control board section there, which channels the wiring out of the way significantly. Also, I was very concerned about the very tight turn on this servo's wiring going round here and down, and after some experimentation I realised the best thing to do is to have it go along the bottom of the servo and then make a channel there. So you'll see that that then has that servo in place more neatly and with less strain on the wire. Okay, moving on now, we've got the audio board there and the main control board there. For the audio board, I had to make a couple of very small grooves on each side to accommodate the board, which is 20mm wide. So there's a slot there, and there's equivalent one on the other side of that. The wiring here is pretty congested. It will be a little bit better when everything's fixed, and I can optimize the wiring length, because there's scope to make some of them just a little bit shorter, which will tidy things up a bit. Move on here. The switch on this side. First, for both of the switches, the holes needed opening out to about 8.5 or maybe 8.6mm, and on this one I've just held it in with hot glue, and I guess time will tell whether that's a suitable long-term solution, or whether we have to find maybe some way of screwing it in. For the one that's in here, I've just got a little spacer. It's actually rolled up as a piece of cardboard, but just a plastic spacer that goes between the switch and that holds it quite firmly in place. Right, as I mentioned earlier, I moved this pivot point so that distance is 30mm, which is roughly the same as that distance, so the angular movement of both halves is the same. But this just being wood, it isn't standing the test of time, and this fixing is getting loose. If there's with the possibility of getting an aluminium bit in there before the exhibition, that would be kind of handy. Right, battery, standard nickel metal halide. The switch, I made a slot in here to hold this end of the switch. At the moment I just put glue to hold the other half, but again, if we could build up the plastic so that there were a slot here as well, then that would make a very neat way of holding it. I've just put it so you could just slot in, and there are corresponding slots in the other side, but since the switch is predominantly in this side, the slots here are nowhere near as deep. Then moving on, and I also put a little block here to stop the battery moving and hitting the switch, because that is a potential hazard. If the switch were to short out the terminals there, then things might get a bit warm. Right, back here, this little board is the 6-volt regulator, so we don't overvolt the servos. The solenoid and the audio runs off the full battery voltage in order to get maximum power. And then lastly, for the charger socket, I didn't want to go with a 3.5mm phono, because they're not really suitable for DC. So I've got a small proper DC connector. this needed the pocket here milling out by 0.5 millimetre on this side and by 1 millimetre on this side, because you'll see that the hole is not quite in the middle there. So and also these bits here need to be milled out rearwards a little bit to hold the wires. So and on the top, because the wires coming off there, there's just a little bit of milling out on that point. Okay, I think that's it for now. So I'll just connect it back up and then we'll see it working. Have the units fully assembled and ready to run. The on-off switch is on the bottom, and reference there's the charging socket. So if we just first turn it on, then press the open, fire, and fire, and then close it. You just run through that again. Open, fire, and close. There is a bit of servo noise, which I don't think I can avoid. If I stop driving the servos, then the weight is such that the unit just collapses. So I think we probably have to accept that. Of course, pressing the buttons too quickly means that they get ignored. Again, open, fire, fire, and close. And switch it off by moving the switch forward. And for charging, it's just a simple matter of plugging that into the back, that main socket, and light is red while charging and turns to green when it's fully charged. Okay.